So then I started thinking about it in a different way. Instead of inclusion-exclusion, could I just have one thing that I am adding together a bunch? So I take, I'll do it with lines. That's they do. Just this one dimensional. So when I added two edges together, I took and then I subtracted their shared point vertex. Yes. So we are intelligent math people, and we have big fancy words for things that have X's in them. It's a plus. Mess it up. Or, so I invented a new shape, a new thing, a new object of thought. One of those. So what is, we're trying to make this. So we take two of these, that's this, that's that, and then we need to close it off, so add back another. So here we don't need to be adding and subtracting and keeping track of how many things that we double counted, because it's just this. And then we could add as many of these that we want. To make a big old chain of these. These are, I think of them like puzzle pieces. So it's a puzzle piece, so it's got a puzzle piece that has an innie shape, and then there's an outie shape. Oh man, that's exactly where the glare is. Okay, I'm gonna redraw this because this is, okay, that sounds good. Alright, I'm gonna redraw this because it's an important point. Shape. So this is something you can stick something in. That, so you can take as many of these guys as you want and hook them together. And then, well, here we need to recap it, so I'll make up what a cap looks like. That must be something like that. And I named these shapes lakes. So like, there's a, like I don't know if you ever had a train kit, and there are little tracks they could put together. And so there's a lot of them you could just like put together all over the place, and then there's some that were things that were ending. So links and caps. And of course there are similarities for bigger dimensions. So what, instead of an open-ended circle, like we know what an open-ended circle is, we've used that before, so what is, be like an open-ended line or a face? How about a dotted line? Sounds good, sounds good. So you could have one of these, and then you could add a bunch of them together, and then, alright, how about these points here? Being shared? Yes, so this is sort of open-ended here. So what's the cap look like? It's just a one-dimensional lower guy, an edge altogether. Just like this is one-dimensional lower from the line that we're trying to make. And then this would give us one, two, three, that's something like that. else? No. Probably it's in my notes. I should probably get those out. So I showed all of this stuff to one of my professors, and he told me about the Euler characteristic. Euler is a genius, and he said everything. It's kind of annoying. You think he did something original, but no, Euler did it in some journal of his. I didn't feel like publishing. So, Euler characteristic, I'm sure you know what it is. It sounded a whole lot like my inclusion-exclusion idea, because you're adding, then subtracting, adding, subtracting, adding, subtracting, blah, blah, blah. And I think it actually is inclusion-exclusion sort of idea that it comes from. But I'll write it down. So you got points minus edges, or vertices, yes. So vertices minus, these, and then add back faces. And I think this was, but the way that my professor presented it to me was just about two-dimensional surfaces existing in 3 space. But of course, why not? It's expandable, and it's the opposite of expand, retract. So you could just not have one of this, so you could just have these two. Vertices and edges. If you want to talk about the sort of thing that we're talking about. So, another application to graph theory, where you're just talking about vertices and edges. And so you can have an Euler characteristic for a particular graph. Because we talk about graphs all the time, and about cycles and paths, but we're getting ahead of ourselves. So what's the next thing? We want to subtract a 3-face. Da-da-da-da-da-da. And so on and so forth. And then, of course, this is all existing for whatever it is, because if you don't have any faces, you don't have any 3 faces or anything, then this is just 0 and 0, so you can just use the same formula for everyone.